In this video, we're going to use the binomial theorem to find the indicated term or coefficient of a binomial expansion. And we want to do it without expanding the binomial. I've done some similar to this. This will be a little bit more involved, maybe a little bit more different. But let's just remind you about what we're talking about here. Here's the binomial theorem. Here's an expansion of x plus y to the fourth. You go ahead and expand it. The theorem tells you the powers on the first term, in this case the x decreased by 1. It goes 4, 3, 2, 1, and then x to the 0. And then on the y, they increase from the first term. It's y to the 0, y to the first, y to the second, and so on. And then this formula here, n I equals n factorial, n minus I factorial times I factorial, gives you the coefficient. Just a quick review here. You set this up like this for select 2. And this is your formula for combinations used a lot in probability. So this is your n, this is your I, so it goes like this: 4 factorial over 4 minus 2. If you look at the formula, so that's 2 factorial. And then times I factorial, and I is 2. Remember, the 4 factorial means consecutive product from 1 to 4. So it's 1 times 2 times 3 times 4. Or 4 times 3 times 2 times 1. 2 factorial is 2 times 1 or 1 times 2. So 4 factorial, you multiply that out. 4 times 3 times 2 times 1, that's 24. 2 factorial is 2 times 1 and 2 times 1, so that's 4. This is 24 divided by 4. So 4 select 2 is equal to 6. So in this expansion here, and if you're looking at, say, this one here, say the power here is 4, this would be 4 and this would be 0. 4 select 0 would be 1, so the coefficient is 1. If I put a 4 there and a 1 there, that would give me 4 using this formula here. And notice here also that the power on the y is 1 here and it's 1 over here in this formula. On this one here it's 2, it's just 2 there, it's 3 there, it's 3 there. That's the way it goes. And these powers always have to add up to whatever the power is in the binomial. There's a 4 there, over here in this one, 3 and 1 is 4, 2 and 2 is 4, and so on. And also realize that every term of the expansion will have the product of the two terms, in this case x and y, except for the power is 0. In the first one, y, it has y to the 0, that's 1. In the last term here, which is actually the first term of the expansion, the power of the x goes to 0. X to the 0 is 1. So we're going to use basically this formula right here. It's pretty much implied from what we have. If you want the jth term of the expansion, the exponent on the y, and keep in mind here the terms are x and y, but it could be, the first term could be 3x, the second term could be 3y or 3y squared, but it's the same application. So if you want the jth term, the exponent on the y should be 1 less than that, and then they have to add up to whatever the power is. In this case would be n. So notice here 2 and 2. This is the third term here, and notice the power on the y term is 1 less. This is the fourth term here, xy to the third 4, coefficient of 4. The power is 1 less than the position. Y to the fourth is the fifth term, and the power on the y is 1 less than that, 4. So we're going to use that along with this formula. So let's go to the first one then. So here's the way it works. If you're looking for a specific term of the expansion, find the terms of the binomial, x and y. So write those out, x and y. And then if you want for a third term, the exponent on the y, as we pointed out a while ago, has to be 1 less than that. So this should be 42. And these have to add up to 50. Okay, so this should be 8 then. 8 and 42 is 50. And then the coefficient is obtained from this formula for combinations. The top value is always the power, that's 50. And the second number here is whatever you have here on the y. It's 42. So this would be then, if you did it manually, this would be 50 factorial over 50 minus 42 would give me 8 factorial times I factorial. I is 42, so it'd be 42 factorial. And we could go ahead and reduce this out and then do the multiplication. Either way, this is gonna be a large number. So I would recommend that you use your calculator. We did this on earlier video. So you want to find combinations of 50 things taken 42 at a time. And this should be 50. Go to 50. Go to probability. Number 3. Then 42. Hit enter. And there you have it. So it's a large number. 536,878,650. That would be the coefficient right here. That would be this coefficient right there. They only want the term. 43rd term. So it's 536,878,650 times the x to the 8th and the y to the 42nd. Now let's go to the next one. The coefficient of x to the 0. So in the first one we did, we're looking just for the term. Or for the whole term, but only the 43rd term. Here we want the coefficient only of x to the 0. So let me rewrite this so it has the form we need. So this should be an x squared plus, write it in the regular form, and then minus 1 over x. I'm going to write that as a negative x to the negative 1 power. 1 over x is the same as x to the negative 1. So put parentheses on this, and this is 18. Okay, so the terms of the expansion are x squared and negative x to the negative 1. So I'm going to write these out over here. I'm going to put it in parentheses. It's the product. So now we have to put powers here. It's not asking for a specific term here. It just wants the coefficient of x to the 0. So we want to select two numbers that add up to 18, so that when I put the powers on these, I get x to the 0. So let's see, we can try a 6 here and a 12 here. 6 and 12 is 18. And then 6 x squared to the 6th power, you multiply the exponent, so that'll give me x to the 12th. Here, power to a power, multiply the exponents, that'll be x to the negative 12. And of course, you're also taking the negative 1 to the 12th power, so that's going to become a positive 1. So this will give me x to the 0. Okay, multiply those out, x to the 0. But what I want is the coefficient. Using the formula, this should be, the n in this case is 18. And the number in the bottom should be, again, whatever you have for the second term. The second term here, remember, is minus x to the negative 1. So this should be a 12. There you have it. And then we use the calculator to compute this out. So it should be 18 over to math, then over to probability, and then number 3. And then we need 12. Number of combinations of 18 things taken 12 at a time. That's your formula. Hit enter. And we get 18,564. So this would be the coefficient here. And this, of course, x to the 0 is just 1, and they only want the coefficient anyway. So this is the coefficient. That's your answer to this one. And just to make it clearer for you, here's your setup for the first one. 50 selects 42, and we did this in the calculator. We got this answer for the coefficient of the term, 536,878,650. That's your setup for that one and the answer. And for this one, again, I rewrote it this way, and then the term for x squared and minus x to the negative 1. And we wanted the coefficient, which is this right here, for the term that would come out to x to the 0. So we said that would work if this would be a 6 and a 12, because that would give me x to the 12th times x to the negative 12. That would give me x to the 0. And then we computed the coefficient using the formula. This is your answer. Thanks for watching. We'll see you next time.